Welcome to Willow Waves, a student-produced podcast that brings together young minds to explore and discuss current events and topics that connect all of us.
Tune in to our podcast to join us on this exciting journey of learning and discovering.
Countdown reaches zero. The engines roar to life on the shuttle's solid rocket boosters, blasting the whole thing up into the air. After around 2 minutes, the SRBs detach from the fuel tank and fuel starts getting pumped into the orbiter. A few minutes later, the fuel tank falls off. Now it's just a crew of 8 and the orbiter in space.
This orbiter was called Discovery, one of the 5 space shuttles to ever go to space.
Space Shuttle was a spacecraft designed to bring heavy loads into space. You may have heard of some of the loads it carried, like
the Hubble Space Telescope and some parts of the ISS, it also helped conduct some science experiments which were done in a European capsule called Space Lab.
Welcome to our podcast where we explore the wonders of space travel. Today, we're diving into the fascinating world of the Space Shuttle Program.
That's right. The Space Shuttle Program was a groundbreaking initiative by NASA that began in the 1970s and ran until 2011. It involved a series of reusable spacecraft that revolutionized space exploration.
The Space Shuttle not only transported astronauts to space, but also played a crucial role in assembling the International Space Station. It was a symbol of innovation and collaboration in the realm of space travel. This is Mr. Loomer. He is a docent at the Smithsonian's National Air and Space Museum.
Why did they make the program?
Okay, well, first off, that was a very good synopsis of the Space Shuttle Program. So, the U.S. history for manned spaceflight was initially to get a man or men on the moon. And that started in the 1960s. And we flew a number of missions that led up to flying to the moon 6 times with astronauts, so 12 people that stepped foot on the moon. But once that was done, and that was a bit of a competition with the Soviet Union. So there was a space race going on, and that was part of what was driving it. Then NASA kind of stepped back and said, okay, but let's do space for real, not just to do one thing. And to do that, we need a way to get people and equipment into space. And we can't just keep doing it by using expendable rockets. That's where you have a rocket, it launches you into space, the rocket is burned up after the mission, you don't use it again. So they developed the concept of the Space Shuttle Program, which is mostly reusable, not completely, but mostly. So as was explained at the beginning, it had 3 components actually, the orbiter, which we think of as the space shuttle, the thing that looks like a kind of a
Brick.
plane, and it was attached to a fuel tank because it didn't carry fuel for its own engines, and then the 2 solid rocket boosters. And all of that except the fuel tank was reusable. The fuel tank was a fuel tank. It wasn't particularly complicated, but it would stay with the shuttle all the way to orbit, and then it would burn up on re-entry to the atmosphere. So, to get big things and a lot of people into space.
So what made the Space Shuttle Program so special?
Well, it was unique and still is, in that it launches like a rocket and it goes straight up. So when it's launching, it looks like a kind of an awkward rocket launch. It's got a bunch of pieces on it instead of just a clean, tall, thin rocket. But the shuttle, the orbiter, looks like a plane because it came back and landed like an aircraft. And that was actually probably the harder part of a mission, not going into space, but coming back from space. Because when you're in orbit around the Earth, in order to maintain an orbit, this is just pure physics, and low Earth orbit, you have to be going 17,500 miles an hour. And when you start coming back in the atmosphere, even though the atmosphere is very thin at high altitude, the friction with the atmosphere would heat the shuttle up to temperatures above 3,000 degrees Fahrenheit. So having something that came back like a plane, landed like a plane, instead of just coming into an atmosphere as a capsule, to have this multi-use vehicle took just a tremendous amount of engineering. It could also bring things back from space, which is unique too.
So
much did it take to get it all working then?
Time or money or both?
Both.
Yeah, okay. The Space Shuttle Program pretty much started right after we finished with the lunar landings, which was 1972. So it was a development during the 70s. The first shuttles were built in starting about 1977, but they didn't fly until 1982. Columbia and Challenger were the first two shuttles built. Discovery, which we have at Udvar-Hazy Center at the National Air and Space Museum, first flew in 1984. So it took a decade, that's a nice round number, to develop the system. And oddly or interestingly enough, it took us a decade to get to the moon. So it was a similar amount of development time. Actually, in terms of real dollars, it might have been less than the lunar missions. We spent a lot of money to go to the moon because, again, it was a competition between countries. That was part of it. But the Space Shuttle Program cost a couple $100 billion. So every time they launched a space shuttle, it cost about $1.7 billion. That was the entire cost of the program divided by the 135 launches.
What made the Space Shuttle Program so special?
What ideas? Okay. Well, the biggest idea, I guess, was all the early capsule missions would come in. The capsule was kind of a blunt object and would come into the atmosphere with a heat shield, the blunt back of the capsule first, and that would get very hot. And it was actually made of a material that would burn off. It was called a ablative heat shield. And that worked if you were only going to use the capsule once. But if you're going to use it again and again and again in the space vehicle, you couldn't afford to have to recoat the entire craft. So they came up with insulating tiles. Why insulation? The space shuttles are actually made out of aluminum, which, like most airplanes, are made out of aluminum. Aluminum is great. It's strong, it's light, but it melts at 1200 degrees Fahrenheit. And as I said earlier, when the space shuttles would start coming back into the atmosphere, the hottest points, the nose, the leading edges of the wings, would heat up over 3000 degrees Fahrenheit. So the entire outside of the shuttle had to be covered with insulation. And they came up with the system of using tiles. Small pieces, they're made out of silica fibers. Silica is a mineral, but mostly they're made out of empty space. That's what gives them the insulating quality. And they did small tiles because they knew that some would be damaged on every mission and would have to be replaced. And it was easier to replace a 4-inch by 4-inch tile than a huge, big sheet. Now, it would typically replace about 200 on every mission. And there are, on Discovery, 24,211 tiles. So that's less than 1% of the tiles.
How did it advance space travel?
Well, it was the first step toward making space missions easier to do. It was certainly a big advance in terms of being able to get big things in orbit. We could not have built the International Space Station without the space shuttles because they carried up in their payload bay huge pieces of the International Space Station. And they carried up satellites, especially special satellites. So Discovery, the one we have here in Washington out at Dulles Airport, carried up the Hubble Space Telescope. So it went into orbit on Discovery. So it made things easier to get to space. Not as easy. Right now, it's become a lot easier. What's going on now in the commercial space business has become just much more routine. In fact, that's why NASA's now working on going back to the moon. They're letting commercial space industry take care of many of the missions the shuttle did. Getting astronauts to the space station now is done with commercial missions. In fact, one launched just yesterday, taking 4 astronauts to the International Space Station. But it blazed the way for that, and it accomplished things that we would not have been able to accomplish otherwise. And the other thing it did was that prior to the shuttle program, every astronaut the U.S. had was a Air Force test pilot or a military test pilot. With the shuttle program, you needed 2 pilots on each shuttle, but by the time it came along, there were all sorts of pilots, male, female, minorities, but they also needed mission specialists, people that could do the missions that the shuttle was flying. And that opened up the shuttle program to being an astronaut to everybody that had the type of talents they needed. They didn't need to be military, they didn't need to be pilots, they didn't need to be men. So it made it a very inclusive opportunity for people to be astronauts.
How much did it take to get it all working? What ideas were thought for it before it was being made? How did it advance space travel? Sadly, the program came to an end in 2011 with the final flight of the Space Shuttle Atlantis. However, its legacy lives on in the advancement it brought to space technology and the inspiration it provided to future generations of space explorers.